My name is Dean Rubine, and I'm going to show you some gesture work I've done here in the Computer Music Laboratory in the School of Computer Science at Carnegie Mellon University. A gesture is a simple hand drawing used to give a command to a computer. Here I'm using mouse gestures to control GDP, a simple drawing program. An L is the gesture for creating a rectangle. The start of the gesture determines one corner of the rectangle, and the other corner is determined by dragging. This gesture creates an ellipse. The center of the ellipse is determined by the start of the gesture, and then the ellipse's size and eccentricity may be interactively manipulated. This gesture creates a line. Encircling some shapes groups the shapes into a single composite object. The composite object can now be copied using the C gesture. I begin the gesture on the object. After the gesture is recognized, I can drag the object around. This curly cue is the rotate and scale gesture. The start of the gesture determines the center of rotation. After the gesture is recognized, I can interactively control the object's size and orientation. This single stroke E gesture brings up some edit points on an object. The edit points are used to scale the object's X and Y independently. The edit points themselves are not sensitive to gesture. Instead, they're dragged around in a normal direct manipulation fashion. This is a simple way of combining gestures and direct manipulation in the same interface. The move gesture begins by positioning the mouse on an object and then pressing the button and making the gesture. The gesture is recognized when the mouse stops moving, even if the mouse button is still pressed. Now the object will be dragged until the button is released. A single stroke X on an object causes the object to be deleted. GDP illustrates how a single gesture serves to indicate both a command and all its parameters. In GDP, the basic interaction combines gesturing and direct manipulation in the presence of application feedback. Ego recognition refers to trying to recognize a gesture as soon as it's unambiguous, rather than waiting for the mouse to stop moving. For example, the rectangle gesture is the only one that begins with a downstroke, so it's recognized almost immediately. The copy gesture is recognized as soon as the curvature of the C is apparent. In contrast, the line gesture is not eagerly recognized, but only recognized when we stop moving the mouse. This is because the line gesture is ambiguous, being a prefix of the move gesture. Using the copy gesture, I can now copy this segment 3 times, quickly making a Necker cube. In this version of GDP, the grouping gesture is trained as a clockwise circle. Since it's eagerly recognized, I must now touch the objects that I wish to group together. Now that I've grouped the components of the cube together, I can rotate it. The rotate and scale gesture gets eagerly recognized after about a third of it has been entered, and then I can interactively rotate and scale the object as before. The delete gesture is recognized about halfway through during its upstroke. As we can see, ego recognition allows gesturing and direct manipulation to be combined in a single, smooth interaction. GScore is a program which allows the user to use gestures to enter a musical score. It's based on some of Bill Buxton's work done at the University of Toronto. This is the gesture for a treble clef. It's simply a drawing of the treble clef. A K gives me a new key signature. As long as I hold the mouse button down, moving the mouse up gives me sharps and down gives me flats. The C gesture gives me a new time signature. After recognition, X and Y control the numerator and the denominator of the time signature. A quarter note B with an upstem, I would simply draw an upstroke starting on the B line. To get an eighth note, I add a flag to that. And to make a 16th note, I have 2 corners in the gesture. To beam notes together, I start on a note, draw a horizontal stroke, and then touch other notes that I wish to beam to. If I make an S on a note, that sharpens it, and a B on a note flattens it. GScore has built into it a variety of rests and other musical symbols, and operations such as delete and move work as they do in GDP. Now I'll make another 16th note, and now I'll try out the gesture for a 32nd note. It gets recognized as a 16th note because I have yet to add 32nd notes to GScore. What I'll show now is how a new gesture for the 32nd note is added. First, I look at the gestures associated with the staff. That brings up this window, and I see a set of gestures. To add a new one, I just click on this button, and that gives me a new gesture. By clicking on that, I get a window where I can enter examples of the gesture. I usually enter 15 examples. Now that the examples are entered, I can give the gesture semantics. The semantics are written in an interpreted subset of Objective-C. Here I get the 32nd note semantics by editing the semantics for the 16th note gesture. Returning to the main window, I see my old gesture still work, and my new gesture, the 32nd note, works as well. Thus, I've added a new gesture to GScore. Now I'm going to demonstrate multi-finger gesture recognition. For this, I'm going to use the sensor frame as an input device. The sensor frame is a frame that sits around your screen and consists of 4 optical sensors, one in each corner, and can detect up to 3 fingers in a plane above the screen. I've done a version of the drawing program that uses the sensor frame and multiple finger gestures. Here I'm training the drawing program on the undo gesture. I usually give 20 examples. Now that I've trained it on the undo gesture, I can try the new gesture out. First I'll make a line. It's the same gesture as in GDP, but additional fingers let me change the color and the thickness of the line. The rectangle gesture is also the same, but I can control the color and thickness and filled property. The 2-finger L gesture is a parallelogram gesture. The parallelogram is hard to see, so I'm going to use the color change gesture to change its color and filled property. Tapping an object with 3 fingers is the grouping gesture. Here I've grouped these 3 shapes into a single object, which I can now copy as a unit. Additional fingers let me change the color and filled property of the object. My goal here is to perform a number of operations which I can later attempt to undo with my newly trained undo gesture. Grabbing an object with 2 fingers lets me interactively rotate, scale, and translate the object. This is done by having each finger attached to a point on the object, which I can then drag around. The X gesture lets me delete an object as in GDP. Now I'll create some new shapes, delete some more, create another rectangle, and now I'll try out my undo gesture. Note it undoes the last operation, and as I move my hand up, it undoes more and more. Get that last shape. And then as I go down, it redoes, so I can go back in history to wherever I like. The multiple finger gesture recognition algorithm is based on the single finger gesture recognition algorithm. Both GDP, the mouse drawing program, and the multiple finger drawing program illustrate how a gesture serves not only to give a command, but also the parameters to the command. Both use the 2-phase interaction, which begins with a gesture, but after the gesture is recognized, becomes a direct manipulation operation. Thus, the power of gestures and the power of direct manipulation are combined in a single interaction.